So let's do exercise 2C, page 119 to 122. So again, just a quick revision. Uh, a right angle triangle. This is the angle O, H, and A. Then tuakaso, tuakaso, tangent theta is O over A. Cosine theta is A over H. Sine theta is O over H. And Pythagoras theorem. A squared plus B squared is C squared. A is here, B is here, C is here. A squared plus B squared is C squared. This is all you need to solve this question. Okay, for this. Okay, let's look at this one. Okay, let's look at this one. Okay, uh, calculate the length of the ramp BC. So again, oh, my A is here, B is here. I'll use Pythagoras theorem. So 30 square plus 100 square equals to C squared. So uh, you can press calculus at this part if you want. This is 10900. Yeah, equals to C squared. So then to bring the square over is square root 10900 equals to C. First, I don't have a calculator with me. You press calculator, then you round off to 3SF. That should be your answer. Okay, for this part. Okay, for this. Yes, okay, for this part. You can give it a try by yourself. The, the next one, the isosceles triangle. Isosceles triangle means that both this side have the same length. They have the same angle here. This isosceles triangle. Calculate this length. So since I know this isosceles triangle, they have the same length, right? Meaning that this 213 cm, I can divide by 2. 106.5 cm. So essentially it's the same as the question above. This is a right angle triangle. This is 106.5. This is the length that I want. This is 132. So essentially it's this. If they're asking, it's the same question as above. They're asking for this, which I can use this my A, this my B, this my C. So the working will be 106.5 square plus 132 square equals to the length square. I don't have a calculator with me, so if I can press out. If not, right, I can just bring the square over directly, becomes square root 106.5 square plus 132 square equals to L, the length. Then the length, I just press calculator, I round off to 3SF cm. Then that's my answer. Okay, for this, can give this a try. It's the same as the as A. Okay, for this part. Okay, let's try question C. So question C is against the same question, as earlier. Similar question, but they're asking for a different part. So you see, yes, the ladder is placed 1.5 meter, ladder that's 1.5 meter long, placed away 0.5 meter away from the wall. So that's like showing the diagram, it becomes like a right angle triangle. My A is here, my B is here, my C is here. So essentially it becomes like this. Is 0.5 square plus the question mark square equals to 1.5 square. So remember, I want to find the question mark. I bring over the 0.5 squared. The question mark square equals to 1.5 square minus 0.5 squared. I bring the square root over first. Since I got a calculator, square root 1.5 squared minus 0.5 squared. Then I press the calculator, I get the answer 3SF. That's my answer. Okay, for this part. From here, I bring over is minus. From here, I bring over is minus because this is plus. So plus bring over is minus. Okay, if this gives it a try, you should be able to get the answer. Okay, okay, with this part. Okay, look at this one. 2. What? Question 2. Write down the coordinates of B. B is here. So at this point here, right, the x is 4 because it's at the x is here. The y, right, is here. At this point, y is 0. So this is 4, 0. The answer is 4, 0. This is the coordinate. If it's at here, right, at here you see. At here the y is 4. At here the y is 4. At here the y is 4. How about the x? The x the x here, right? The x is here. At here the x is 0. So this is 0, 4. You see the difference? At the red cross I draw is 0, 4. X is 0, y is 4. But the one they're asking for B is 4, 0. It's at 4 at x, then y is 0. Can you see the difference for this part? A lot of people get this part wrong. Okay, for this, then calculate the length of BC. So what is the coordinate of C? C is 6, 4. Here is 6, this is 4. X first, then Y. C is X first, then Y. 6, 4. Calculate the length of the line BC. So there's a formula for this. Y2 minus Y1 square plus X2 minus X1 square. Um, okay, for this, then square root. This is the formula. Square root Y2 minus Y1 square plus X2 minus X1 square. Meaning like this. So this is 6, 4. This is 4, 0. So it will become right here. Square root. I I label this as x2, y2. This is my x1, y1. y2 minus y1 squared. 4 minus 0, whole thing squared. Plus x2 minus x1. 6 minus 4 squared. Then you press calculator. You again round to 3SF. Then you get the answer. Okay, for this. Sorry. Okay, for at any point you can pause and rewind and rewatch again to get the solution. Okay, let's move on to the next one. C. C. Mark and label a point D such that the quadrilateral ABCD is a parallelogram. So you see from A to B you move 3 points. Just shift back 3 points. 1, 2, 3. D should be here. There. You see it kind of parallelogram. So D is here. So you don't need to do it the way I do it. On the point you just mark out here. If you know that it's here, right? 1, 2, 3. Just mark out here as D. This will be good enough. Okay, for this. Uh, for each of the following three, use Pythagoras theorem to determine if ABC is 90 degrees. Meaning what? Meaning if to find out if is this 90 degree or not. Meaning uh If this is Pythagoras theorem, this should be 90, meaning that the value of 18 square plus 20 square, this is A and B, this should be the same answer as 26 square. This is the this is what they mean. A and B, A square plus B square should be the same answer as C square. If if yes, right, if yes, right, then it'll be 90 degrees. If no, then it's not 90 degrees. Okay, I can understand this part. So you press calculator, you get the answer. If they are the same, then yes, it's 90 degrees. If no, right, then it's not 90 degrees. Same for B. This is your A, this is your B, this is your C. 3.6 square plus 1.6 square. Is this the same answer as 3.9, 3.9 square? If it's yes, right, then it's 90 degrees. If no, then it's not 90 degrees. Okay, for this, which demand this angle because this is the part where it should be 90 degrees or not. Give it a try. Let's see how is it. Question 4. An aeroplane takes off at ground level until reach an angle 12 degrees to reach a height 10 km. Find the distance d. So this is where you see I have my angle here 12 degree. This is opposite the angle. This is hypotenuse. So OH I have to use sine. Tuakaso. Tuakaso. SOH. So I have to use sine because only O and H is involved. See this part. So sine 12 degree is 10 over d. So uh, remember how do I find out this part? Let's put this over 1, change to a fraction, you cross multiply. This times this, d times sine 12 degree equals to this times this, 1 times 10, cross multiply. Then to find out d, I don't want the sine 12, I bring over, times bring over is divide, d is 10 over sine 12. Then you find, then you press calculator, you can round off to 3SF. Okay, for this, give this a try. The next one. The Merlion is 8.6 meter tall. The point A is 20 meter away. Calculate angle of elevation from the top of Merlion from point A. So angle of elevation is looking upwards from A. From A look up, they meant this one. This is the angle. So they're asking to find the angle with the given value. From the angle, this is O. This is the 90. This is H. But A is here. So the only value I have is O and A. TOA, CAH, SOH. The only one I have is O and A. I have to use tangent. I have to use tangent. So tangent theta is 8.6 over 20. Tangent bring over is tangent inverse. Inverse tangent 8.6. You press calculator, shift tangent. You'll see the minus 1. Then you press out the value. This is angle. Angle is 1 decimal place. Angle is 1 decimal place. Okay, for this, angle is 1 decimal place. Length and others are 3SF. Money is 2 decimal place. Okay, for this, give this a try. You should be able to get out the answer. D. This represents a side view. Calculate the greatest height XZ of the building. Give your answer to the nearest meter. So you see XZ is here. From here to here is 12 meter, right? From here to here should also be 12 meter. So the part that I really have to find is this part, XY, which then I see that this becomes a triangle. These two lengths the same. So technically, right, what I am looking at is just this. Technically, I'm just looking at this. A right angle triangle. this is X, Y, this is W, this is 26.5, this is 26.5, this is 26, this is the one to be found. So again, I use Pythagoras theorem. This is my C, this is my A, this is my B. So 26 square plus the question mark square equals to 26.3 square. Then to find the question mark square is 26.5 square minus 26 square. Because I don't have a calculator, I bring the square over first. 26.5 square minus 26 square. I press calculator. Then because they said they want the nearest meter, I round off the nearest meter. And that's my answer. Okay with this part. Okay for this. Then they say the B. B they say find the angle X W Y. Since I draw the diagram, the angle is here. Which my angle is here, my O is here, my H is here, my A is here. Let me use I can use any. I can use with the value of B, right? I can use any, but since I have the fixed value A and H, I'll use A and H. So it'll be A and H will be cosine. Cosine theta will be 26 over 26.5. You bring the cosine over, shift cosine, get cosine inverse, 26 over 26.5. You get the answer, you round off to 1 dp. Okay for this. So example, let's say you have the value here. You want to use cosine O and H, SOH sine. It's also possible. Sine theta is the question mark answer over 26.5. You bring the sine over, sine inverse, the question mark answer over 26.5. You press calculator, you round off, you'll get the same answer, 1 dp. You get the same answer. You might differ a little bit by 0.01. That is due to rounding, but it should be the same answer actually. Okay for this. If you use the exact values, it will be exactly the same. If not, it would differ. If the difference is 0.01 with your friend, then it was due to rounding. It's okay. Okay for this. Any question you can ask me in class. Can give it a try. Okay for this.